Now that we have our explosion sources set up, let's go ahead and build our simulation. So on this Pyro solver here, under the Setup tab, I'm going to raise the voxel size a bit. Let's not start simulating it any higher res than we really need to. At my scale that I'm working at here, I'm using a voxel size of 0.15. We could actually probably go a little bit higher than this. I'll try a voxel size of 0.25 to start. And for this explosion, I actually found that I didn't need to use any colliders at all. It didn't look incorrect at all to not collide with the ground or the creature. And we talked about how to add collisions to the Pyro sim when we did the dust simulation and the shockwave sim. So feel free to add some collision sources if you'd like to this, although I didn't find it was necessary for my explosion here. So we have our voxel size set. We're not worrying about colliders at the moment. For the starting position of the sim, I just channel referenced this to the first explosion point. So on the first add here, I'm going to right click on that point position parameter, copy that parameter, and then on the Pyro solver, paste the relative reference into the center position here. The start frame is going to be frame 80. And let's set our timeline to frame 80, display our Pyro solver, and then do an initial flipbook of this. So start that at frame 80, and we don't need to do too many frames of our explosion to see how it's looking. I'll set this to go from frame 80 to 150, although I might stop it a bit sooner, and let's see what this looks like. And now reviewing our initial simulation, this slightly resembles an explosion, but it doesn't look very nice just yet. So we're going to change a whole bunch of things to get this looking nicer. So a couple things to look out for are how you're adding temperature into the simulation for one. Now, we initially added a temperature source because that's what the Pyro solver is expecting, just based on its default inputs here, but there are other ways that you can add temperature to your simulation. So you can entirely remove the temperature sourcing here under the Pyro solver sourcing tab, and then if we go to the solving tab under flames, if you expand the temperature option here, we can instead add some temperature wherever the flames are present. So for explosions, this can be a better way of adding temperature into your simulation instead of relying on just adding temperature from your input. So we'll turn this on. I'm going to leave the frame range alone. This is essentially where your temperature is going to be sourced from. If you wanted only the most high flame value areas to add temperature, you could change the flame range here or remap it with a curve to really fine tune it, but I'm going to leave this all default and just crank up the strength a bit. Turn that up to 50. I'm also going to turn up the flame lifespan because everything seems to be dying off too quickly, so I'll turn that up to 10. And we also have some controls here for the expansion of the sim. Now, currently we have some velocity being added to the sim from that Pyro burst source, and that can certainly help with the simulation, but some of this expansion force from where we have high flame values can be much nicer to really drive the explosiveness of the sim. So let's turn on add expansion. I found that turning down this value slightly from its default expansion rate worked well for my sim. So we'll just stick with this as our starting point. And we can also turn on some smoke emission. Looking back at our initial sim, this sim is all flame and no smoke. So we can add in those smoke densities by opening up this option here, turning on emit smoke, and I'm just going to leave this all at the default for now. And because this smoke emission here is going to add the smoke density to our sim, we don't need to explicitly source density either. So I'm going to turn that off on our sourcing tab. So at this point, we're only sourcing the burn field and the velocity. And let's also turn down the velocity as well to 0.5, since we're not relying solely on the velocity for the expansion of the sim. We're getting that explosive expansion mostly from this expansion option here under the Flame tab. So now let's rewind our sim and do a new flipbook. Now this updated simulation is looking a bit better. It's still not looking great, but it's a step in the right direction. And right now, this is very boring in terms of motion, and we need to break this up a lot more with a bunch of disturbance to get some more interesting motion and detail out of this sim. So if you remember from our shockwave and dust setups, I will often use a box in the scene to help me decide what size I want for the disturbance shapes. So I'll just drop in a box here. I'll call this reference size. And just to put this near the creature and near that explosion sim, I'm going to go to one of my explosion source points, right click on that point position, copy the parameter, and I'll paste the relative reference into the center position of this box, or just paste the values, either is fine. And let's display that box and zoom in on it. And sometimes with disturbance, we want to use this to get some pretty small level detail. But in the case of this explosion, we want some of these larger billowing shapes. So I will often use a larger disturbance for some of the smoke breakup, or I should say the explosion breakup. So let's try seeing what a scale of 3 looks like on this box. And that looks pretty good for just some general breakup of the velocity. And of course, we'll use some smaller levels of disturbance layered in with this as well. But I'll try 3 as a starting point. So back on our Pyro Solver, let's go to the Shape tab, turn on Disturbance. I'm going to crank the amount up quite high to 100. And under the Disturbance settings, I'll set that block size of 3. And I'll leave this on 3 max octaves. Leave everything else default as well. And I'm also going to turn down the dissipation quite a bit. So our entire explosion is dissipating very quickly. So I'm going to turn this down to a very low value. We'll try 0.02. And looking back at the simulation again, I also feel like this isn't rising quite as quickly as I'd like. I'd expect this super hot explosion fireball to rise much more quickly than this. And we can control that with the buoyancy controls on the simulation tab. So this uses the temperature to determine how fast this is going to be rising, and using these reference temperatures allows us to essentially use values more in the 0 to 1 range for the actual simulation values for what those fields contain, but then we can remap the actual temperature values to what that actually means in terms of real-world temperature units, which may be a bit of a confusing way to present it, but all you really need to know is that you can change the temperature here to make it rise more quickly or more slowly. So if we want this to rise faster, I'll turn up the reference temperature to 5000. And while we're on the simulation tab here, I'm also going to turn on advection reflection. So this will help to maintain some vortices in the simulation, which could give us some more detailed, interesting results in our explosion. So I'll turn this on to single project. Double project is much slower. It's going to take a lot longer for your sim. Single project, I don't believe, is a huge hit in terms of simulation time, so we're just going to stick with that. And because this is still a very quick simulation, I'm going to start increasing my resolution for some better results here. Back on the Setup tab, I'll try turning my voxel size down to 0.15, then display the Pyro Solver, go back to our camera, and then run a new flipbook. And now our updated sim is behaving a bit more like the fireball that we expect, but it does have some strange behavior to it. The initial frames are looking pretty alright in terms of the overall style of the motion here, but after the first, say 15 frames or so, we are getting this very wispy, overly energetic motion in there. So we can solve this by animating our dissipation. And also, the look of our fireball doesn't look too convincing just yet, but one of the tricky things about doing explosion work is to not get too hung up on how things look just out of the simulation like this, because the simulation is only half of the job when it comes to doing explosions. The other half is working on the shader to really dial in the explosion look based on the fields that we have from the sim. And we'll take a look at that some more in a moment. But before we take a look at that, let's rein in some of this behavior that we're seeing here. Now, if we go back to our Pyro Solver and go back to the Solving tab, then Shape, and under our disturbance here, we can animate the overall disturbance amount so that we don't get that really wispy, swimming around, energetic thing that we had in the last version. So I like to use fit functions anytime that we can get away with just a linear animation between 2 frames. And in this case, I think that will suffice just fine. So I'll do a fit function and we'll fit the current frame number from frame 90, so it's maintaining its full disturbance for the first 10 frames, up through, I'll try frame 120, and we'll maintain the full disturbance of 100 up through frame 90, and then by the time we hit 120, we'll try animating this down to 30. Of course, you can set keyframes instead if you'd like, and we can do that perhaps on the dissipation here. And I found that for this explosion, because the overall shot length is fairly long, going up through frame 240, I didn't really want the smoke to be completely disappearing by the end of the shot. So by the end of the shot, I wanted to animate the dissipation all the way down to 0. And this is one case where maybe I want a bit more control over that fall off based on the handles on our keyframes. So in this case, I want to keep our current dissipation amount up through, we'll try frame 140. Looking back at our flipbook, frame 140 gives us most of the time that the fireball exists. By the time we get to around frame 140 or so, this is mostly turning into smoke at this point. So at frame 140, I'm going to alt-click the dissipation amount to set a keyframe there. And I'll go to our final frame of the shot, 240, set that to 0, and set a new keyframe there. And then if we shift-click this parameter, this will open it up in our animation editor, and then we can hit Space G to frame this up in our full animation editor view here. And then we can control the slope on our curve to really finely control the rate at which this dissipation is happening. So if I want the dissipation to turn off fairly rapidly, maybe I'll drag the slope down quite a bit so that we get this rapid fall off of that dissipation amount after frame 140. And this is totally an optional step. It's up to you if you want to mess around with this stuff, and you can certainly spend a lot of time tweaking the animation on your various properties like dissipation and disturbance and etc. And once again, looking back at our latest simulation, I feel like the flame values that we're adding are kind of dying off a bit too quickly. So in addition to playing around with the flame lifespan, we can also try just emitting more values into the flame field. So going back to our Pyro Solver on the Sourcing tab, and then where we're sourcing burn into the flame field, we can try doubling that up. I'll turn that scale up to 2. And we can also finesse this behavior a bit further with some microsolvers. So diving inside the Pyro Solver here, we have lots of options for various microsolvers that we can add to our simulation. In this case, I found it really helpful to add an additional disturbance on top of the disturbance that we've set on the main controls of the Pyro Solver. Looking back at the latest simulation, we are getting some decent motion in there, but we could get a little bit more detail at the voxel level. And to get that really fine detail, sometimes this continuous mode can be quite helpful. This will essentially randomize that disturbance per voxel to get you the finest level of detail possible. You do have to be a bit careful with this because you can really just turn your simulation into a fuzzy mess with too much of this continuous disturbance, but it can certainly be helpful for adding some of this extra detail. Of course, you could do lots of iterations to tweak the strength and reference scale of this, and for the continuous mode, the reference scale is practically another control over the amplitude of the effect. For this sim, it seemed to work pretty well to turn that up to 0.8. And the other bit of microsolver control that I'd like to add is some control for the wind force, like we set up with the dust simulation. So I'm just going to copy that wind setup from our dust sim. So let's set our scene to manual so it's not updating, and go over to our dust setup. And I'll copy this gas field VOP for that custom wind. Then go back to our explosion pyro solver, paste in that custom wind gas field VOP, and then let's merge this with the disturbance, and then wire those merged microsolvers into the force output. However, we may want to set a different wind height min and max for our explosion sim because the terrain is actually sitting at a different Y height than the terrain region where the dust simulation was happening. So I'm going to jump over to our dust sim and let's copy this wind height reference from there as well. Then go back to our explosion setup and paste that in here. We don't really need this sim scale transform if we're setting up the box at sim scale. So let's display that box by the wind height reference null and turn our scene updating back on. And then let's move our reference box for that wind height into position. So I'm going to move this box up a bit so that we don't have any wind force right near the mouth of the creature there. The wind force only starts once it gets to be a bit higher than the creature. So it's going to ramp up that wind force from the minimum Y value of this box up through the max. So we should have a fair amount of wind influence once any smoke rises to about this height here. So now going back into our pyro solver, we can link our gas field VOP to this wind height that we've set up. And I'm not really going into the inner workings of our custom wind VOP here, since we already talked about that with the dust setup. If you'd like a refresher on that, then I'd encourage you to look back at how we set that up with the dust sim. And since we copied over this gas field VOP from our dust setup, I'm going to try leaving all the same values except for these references to the wind height min and max. Because we just copied this over, we also copied this with its relative references that are still pointing to the wind height reference and the dust setup. So we need to change this and point this to the explosion wind reference instead. So for the wind height min, I'll point that to object/explosion/wind height ref, and I'll copy this whole thing, paste that into the max parameter, and change this from Y min to Y max. And if we left click on these parameters again, you can see the values that those are picking up. So this will be ramping up our wind influence from a height of 51, where it's going to get basically nothing, up through 241, where it's going to get the full wind influence. So this should add quite a bit to our realism of our sim as well. One thing that's a common problem with effects simulations is when they feel like they just exist in a vacuum. It just feels like a fake environment. In a real outdoor scene, you would expect maybe some amount of ambient wind or something to disturb the path of the simulation. So adding that extra wind can really go a long way toward making our simulation more realistic. So we've updated quite a few things here. We've added that wind force. We've added some extra very fine detailed disturbance down at the voxel level with this continuous disturbance mode. Back on the Pyro Solver, under the Solving tab and Shape, we've animated down our dissipation from frame 140 to the end so that our smoke doesn't completely dissipate away. And we've also animated down our disturbance so that we only get full disturbance at the beginning of the sim and that it calms down a bit after that. And in addition to all that stuff, we've also updated our sourcing for a bit more burn influence as well. And because the last iteration of the sim was going quite a bit slower since I had turned my voxel size down for more resolution, it went up to about a half-hour sim. While we're still testing things and seeing if things are working properly, I'm going to turn this back up a bit because that's a little bit slower than I'd like for testing right now. Turn that back up to 0.2. And I had also mentioned that the simulation is only half of the job. The shader is really the other half of what really makes an explosion look like an explosion. So before continuing much further, we can get our temporary shader to look a little bit closer to an explosion. So if we go to a frame where we have a decent amount of this explosive propagation, like perhaps frame 90, then we can also start tweaking our temporary shader a little bit so we get some slightly better feedback in the viewport. So after making these changes, I'll go back to frame 90, re-enable our simulations because I had turned the brain icon off while making some of those tweaks. Let's reset our sim and display the Pyro Solver. So after letting those initial frames cook, we can zoom in on this fiery explosion here, and you can tweak the shader a bit at this stage. This isn't going to be our final shader look by any stretch, but you can affect your viewport feedback a bit. So on the Pyro Solver, if you go to the Look tab, this is going to control this shader that it's assigning to your simulation. If you middle mouse on the Pyro Solver, you can see the output includes this shop material path, which is a path to the shader that it's using for its display. So if you cache out this simulation, it's going to include this material that we've specified on our Pyro Solver here. So we can go ahead and start tweaking the look of this a bit. We can perhaps turn up the density of the smoke, make this a bit darker, because I kind of want this explosion to have a bit more of a darker sooty smoke, not a very light colored one. So if we set the color to HSV, I'll turn the V value down to 0.025 for a very dark smoke. For this fire emission, we can crank up the intensity a little bit. I'll try turning that up to 3. You can see this is already turning into a much more believable explosion. It still doesn't look great. It's still a bit low res, and we need to see this properly rendered to see it in all its glory, but it's certainly getting a bit closer. And then finally, if we scroll down to the bottom here, we have some control over which fields it's using to control these various parameters. So for the smoke density, we're going to leave this set to the density field. We're not really worrying about diffuse color because we're not doing some sort of stylized, colorful simulation here. The fire color I will leave on temperature, but ultimately when we tweak up this shader for the final rendering, we're actually not going to use this flame field at all. This flame is really useful for driving our simulation here, but ultimately we're going to use the temperature field for the shading. So for the fire intensity here, it's up to you if you want to leave it on flame just while you're viewing your simulation results, or you can try displaying the temperature instead. You can see that changing this out for the temperature doesn't really change our look very much, and this could potentially give you results more like you'll see with your final shader. If we do leave this on flame, then you can also see some issues associated with this if we start to turn off some of the export volumes. So on this Pyro Solver here, if we go to the Export tab, then we can turn off some of the volumes that we don't need when rendering. So we don't need this color volume, which actually isn't part of our output anyways, because we're not doing some sort of a stylized colored sim. Currently, the only volumes our PyroSolver is outputting are density, which we need for the smoke, velocity, which we need for motion blur, temperature, which is what we're ultimately going to use to drive our shading, and it's also including this flame, which, as I said, is very useful for driving the motion of the simulation, but ultimately we're not going to use that flame for the shading, we'll just utilize temperature instead. So because we're not really using the flame for any of our rendering, we can actually remove that from the fields that we're exporting here. So removing CD doesn't make any difference because we don't have that anyway. Removing flame will make a difference because by default, this PyroSolver shader was using that flame to drive that sort of fire emission intensity. And it is a good idea to not include any more volumes than you really need in the output of your sim when you're caching it to disk, because these explosion sims can be quite heavy and it's good to keep things as optimized as possible. So certainly it's good to avoid outputting any unnecessary volumes to disk that we're not going to need for rendering. So now we're only getting density, velocity, and temperature in our sim output. And we could also optimize our output a bit as well by converting this to VDBs. But when we remove that flame field, we're losing the look of our Pyro shader that shows us that nice flamey emission. So back on the Look tab here, this is why I mentioned that you can change the field that it's using to drive the fire intensity. So if you want to delete that flame field from the PyroSolver output, but still maintain a decent look on this simulation shader, then it can help to set this fire intensity binding to temperature instead. So now we have a much nicer look for our explosion. This will certainly help us judge our sim as we're dialing in our final bits of finessing on this. And we can also fine-tune the display of this a bit by playing around with the fire color ramp. Right now it's using this physical black body to determine the colors of that fire, but you can set this to a customized ramp if you want your own manual control over this. I'm going to leave this on physical black body for now and see how this looks in our new flipbook. And because I'm feeling pretty good about how our explosion simulation is looking at this point, I think I'm going to cache this out to disk as we flipbook it so that we have this existing cache if we like the results of our sim. When we just do a flipbook without caching this out, if we decide that we like the results of our latest sim, then it's kind of a waste of time because we haven't actually cached this and we need to go back and rerun the thing to cache it. So sometimes I like doing these steps together. So let's drop in a file cache, connect our PyroSolver to that, call this cache explosion. I'll Control-Shift-Click to remove the expression on the start and end frame, and sometimes I like to channel reference the start frame of our cache to the start of the simulation. So on the PyroSolver, I'll go back to our start frame parameter and copy that, and I'll paste the relative reference into our start frame here. And let's point this to our jobs directory under Geo and Explosion. I'll make a new directory called explosionsim.vo1 and set the file name to explosionsim.$f3.bgo.sc. And then to make sure that we're writing these files to disk as it flipbooks our simulation, we can set the file mode to either write files or automatic. I'll just try setting this to automatic and display that file cache. And now if you look at that location on disk, this has written out that explosion sim as it's displayed that frame. So now with that file cache displayed, I'm going to go back to my explosion shot camera. And because I'm feeling lucky with this sim, I'm actually going to go with our slightly higher resolution here. I'll set this voxel size to 0.15. Let's reset that simulation. And resetting our simulation after setting our voxel size to 0.15 actually hasn't written a new value to disk because on the file cache, this mode is set to automatic. So you can see our PyroSolver output is 0.15 in terms of its voxel size, but the actual cached frame is 0.2. So this automatic mode is only caching out that frame if it's not already existing on disk. So if we set this to write instead, then this is going to guarantee that we're overwriting whatever's on disk there. So now that we've set that to write, we now have this reading in the correct data with this voxel size of 0.5 because it's rewritten that cache frame. So this could potentially be a little bit safer to use this write files option, but that kind of depends on your personal workflow preferences. So now with that set, and our simulation resolution turned up a bit, we'll do a new flipbook, and for this one, I'm going to try running this on the entire frame range. And if this doesn't look promising by the time it's partway through the sim, I may kill it early, but let's see how it goes. Now after the latest updates, our simulation is looking quite cool. So we can go ahead and start rendering this, although there are a couple little issues that we could fix first. It's up to you if you want to start doing test renders or fix any little problems like this at this point. But we are running into this issue where our explosion is hitting the bounds of our simulation. So you can see mainly in this top section here, the explosion is just getting clipped off there. So we need to add a little extra padding at the top of the simulation to prevent this from getting clipped off like that. See, it's getting totally flattened out in that spot there. And the other thing we can address is a bit more of a subjective artistic note, and that's that I would like this explosion to be a bit bigger. So you could play around with perhaps the expansion settings on this. That could be one good way to get this to be quite a bit larger, but you can also address that sort of thing post-simulation as well. And I always encourage people to fix things after the sim as much as possible, because oftentimes you can spend tons and tons of time just running multiple iterations of your simulation to address a note when it really can often be fixed with just some sort of tweak after the simulation is cached out. In this particular case, we can actually make the sim quite a bit bigger with a post-sim transform. So if we go back to our cached out sim here, on this file cache, I'm going to set this to load from disk. And let's go back to one of those earlier frames. Perhaps around frame 90 is a good one to look at. And we can make this explosion quite a bit bigger just by transforming the sim. And when we do this, we have to make sure that we use a constant pivot point. So if we drop down a transform SOP after our cache here, if we were to do something like use our centroid transform preset, if we display that transform, and then scale this up, that technically works, but this is going to probably behave pretty weird because this center point of this explosion is going to be changing on every frame. So this is probably going to look pretty strange with that changing pivot point all the time. So instead of using this centroid pivot, I'm going to grab the position of the first explosion source. So if we go back to our add SOP where we've added the explosion source point, I'll right click that, copy that parameter, and then on our transform SOP, you could paste in relative references or just paste in the values. I'm just going to paste in the values from that add SOP. But since we already have a centroid expression in there, it doesn't seem to work properly, so I'll Control-Shift-Click the pivot translate to get rid of that expression, and then right-click and paste in those values. And it's not very obvious where this pivot point is visually in the viewport when it's covered up by the explosion like this, but if you hit W to go into wireframe mode, and then hit Enter in the viewport to grab your transform tool, then you can see exactly where the pivot is going to be for this transform. And you can move around this pivot a bit if you'd like. You can hit Insert to go into that pivot editing mode and perhaps move that pivot around a bit to tweak exactly where the origin of this transform will be. Then hit Insert again to get out of that mode. So if we hit W again to get out of our wireframe display, you can see our scaled up explosion here. And this scale of 1.85 is probably a little bit more extreme than we need. I think something more like 1.5 gives us a large enough explosion without this getting to be just ridiculously large. And actually, before we run our new flipbook to see what this scaled up simulation looks like, I'm just going to turn on the terrain display so that we can see this in context a little bit better. Set our viewport to show all objects, because the way this looks in context with the terrain may affect our artistic judgment with the size and shape of this explosion that we're happy with. Maybe I'll just jump up to the object context and turn off the display of some of the creatures that we don't need to see right now. Then go back into our explosion setup. And if you don't want this bounding box to be visible around our explosion sim there, you can go to our display options and just set it to smooth shaded instead of wireframe unshaded. And now with all that extra stuff visible, let's run a new flipbook and see how the scaled up sim looks. And now checking out the flipbook of our scaled up sim, this is looking pretty awesome. This is working much better. It's a lot more impactful and epic, and just applying this simple transform on the explosion was much easier than playing around with settings like expansion to get the simulation just right, which can take much more time. Sometimes you do need to go the simulation route and dial things in that way, but it's always great to use these quick little tricks when you can get away with them. So we do still have this issue where the top of the simulation is getting clipped off there. So we do need to fix that. So if we go back to our simulation, bypass our file cache, and then go to the first frame where we see some actual data showing up, then we can use this to make sure that our padding is working. And for this, it's very helpful to make sure that you're in wire shaded mode so that you can actually see the bounds of your sim. But you do have to watch out for something, because this is getting exported as a VDB, and VDBs by default will throw away all of the unnecessary areas that they don't need to store data in. So this could be confusing when you're trying to dial in your simulation padding. So on the Pyro Solver here, if you go to the Solving tab and then go to Advanced, you scroll down to the bottom, there's this Resizing tab that gives you some control over the padding in the simulation. That's how much empty space it's going to maintain on all sides of the sim. But if you start turning up this padding, then you won't see any changes in the output here, because this is exported as VDBs. So you can really crank up that padding to 10, and if we reset our simulation, that'll make sure that the output we're looking at is updated with that new padding setting, but we're not seeing anything different in here. We're seeing no extra gap around our actual volumetric data. And as I said, that's because this VDB that we're outputting is by default just throwing away those empty spaces. So when you're dialing in these paddings, you may want to turn off this convert to VDB so that it shows you the actual padding that you're working with here. So with the convert to VDB turned off, this is now outputting native Houdini volumes, and the display does seem to be a little bit glitchy here. It's actually not showing me the box at the moment. If I go to smooth shaded, then back to wireframe, it's still not showing it, but it does show us the box if we step back a frame and then forward again. You can see there's all of this extra space around that bright explosion spot there. It's just a little bit weird that the box is disappearing when I move the camera. Just a display bug, I suppose. In any case, this is much more padding than we actually need. So back on the Solving tab and Advanced and Resizing, we can dial in a more appropriate padding value here. I'll set it back to the default of 0.3, and that should be pretty reasonable. But judging by our sim results, it seems to not be enough. So let's see what 1 looks like. That's not much help. I think I'm actually going to go up to 5 just to make sure that this is really not clipping anything off. 5 is giving us a fair amount of space here. And by default, this Pyro solver is doing a sparse solve here, so it shouldn't need to do a ton of calculation on all of the empty space. I would watch out for an increase in simulation times as you increase your padding. Hopefully it's not too bad, but it's just something to watch out for. But in any case, with this expanded padding here, hopefully that'll be enough to avoid the issue at the top of our volume getting clipped off. So I'll rewind the sim, re-enable our cache. I'll version up the cache to sim version 2, turn off load from disk so that this is writing files, and then I'm going to do a flipbook of our version with the post cache transform on it. So back to the explosion camera, and let's see what this new flipbook looks like. And now reviewing this new scaled up simulation with the increased resize padding, this is looking much better. If we step through the simulation and just look at that top portion that was getting clipped off before, it looks like everything is all good and we're not seeing any issues with the top section getting all flattened out like we saw before. So that's all looking great. So I'm going to go ahead and cache out the entire frame range. But before I do, there's one more thing I should note regarding the resolution of our volumes in the viewport here, because sometimes you might find things looking low res even though you're trying to cram tons of actual resolution in there. And sometimes the problem can be that the viewport is trying to optimize the display and limit the number of voxels that it's going to show you. So with your mouse in the viewport here, if you hit D, that'll bring up your display options. And then if you go to the texture tab, you can see there's this option to limit the resolution of 3D textures. And this is a very low default. This is going to limit it to just 256 voxels in X, Y, and Z. So let's see if our explosion looks much nicer once we turn that off. So if you turn off that limit resolution option there, you might want to save that as your default. Then if we close this, we wouldn't necessarily see anything immediately because we haven't told Houdini to refresh the display at all. So if we just step back one frame, now you can see that this volume is looking much nicer than it did a second ago. So we were really suffering from the viewport settings clamping down on how much of this voxel resolution we actually see. And it did take my computer a moment to update this with all of that voxel resolution in there. So you may want to keep a resolution setting turned on there. It's kind of up to you and how much you're struggling with the limitations of your machine. And now that we've increased the quality of this explosion display, I'm going to turn on load from disk for those sim frames we've just written out previously, and then do a fresh flipbook to see how much better this looks now. But for this one, I'm also going to bring back the creature jolt animation just so that we can appreciate that bit of difference that makes in conjunction with the explosion. So instead of displaying the time shift for that creature jolt, I'm going to put my template display on the actual animated one. And let's see what this looks like. And now checking out our updated flipbook with the voxel limits turned off and our viewport display options, this is looking much nicer and more detailed. And if we compare this to the previous version, then you can see how much the previous version was suffering due to those viewport display limitations. Maybe I'll go to the same frame just for a better comparison. And yeah, this certainly looks much nicer with this better display setting. And it's kind of a subtle thing, but you can see how The animation of the creature also helps to sell the impact of this explosion, and if we were to view this with the shockwave element as well, all of these different elements really come together to make a much more convincing end result. And pulling up our rendered and comped shot, all those combined elements look like this. So next we're going to take a look at baking some scattering effects into the volume and then rendering this explosion. And in preparation for doing that rendering, I'm going to go back to my Pyro solver and re-enable this VDB conversion on the export tab, because we had previously turned that off to test out the resizing padding. So I'll turn that back on for some more efficient caches to disk, and then on the file cache, I'll save that entire range out.